Question number 3 wants to determine how many solutions this system has. This is a system of linear equations. This is a linear equation, and this is a linear equation. There are 3 things that linear equations can do in a coordinate plane. So if I have a coordinate plane with an x and a y axis, if I graph 2 lines, there are 3 different things that can happen, as I mentioned. They simply can cross somewhere in the coordinate plane, and if they cross somewhere in the coordinate plane, they have one solution. And the only way they cross is if their slopes are different. So this means the slopes are unique or different. Another possibility is you could go in the same coordinate plane and you could have 2 lines. This time I'll represent them in green, and I'm going to do my best to make them so they are parallel. If they're parallel, then their slopes are identical or the same. In this case, there are no solutions. Okay, so I'd probably better come back and clarify on this one. The slopes are the same and they have a different y-intercept. Okay, so this y-intercept is different than that y-intercept, but the slopes are same, so they're parallel and they'll never touch. And if they never touch, there are no solutions. There's one more possibility, I'm going to represent these in blue, that I could possibly have 2 equations that end up graphing the same line. So the 2 equations could simply graph one line over top of the other line. They're going to look differently, but realistically they're just multiples of each other and they're the same. In that case, that solution traces one line over top of the other. That means they have the same slope and the same y-intercept, which means they touch everywhere. So in this case, they have an infinite number of solutions. So to summarize, we could have one solution if their slopes are different. They can have no solutions if they have the same slope but a different y-intercept. Or in the last scenario, if they have the same slope, same y-intercept, there's an infinite number of solutions. So all is going to hinge on your slopes and your y-intercepts. So I'm going to clear that idea off and start back with our original system. So what I'd really like to know about this system is, what is the slope? So to me, it's easiest to get the slope by solving this for y, which means y is going to equal 4 halves minus 3 halves x. And I really am not that concerned about, let me take that mark back off. This is going to be 3 halves x. So it's 2 minus 3 halves x. Okay, so that's my first equation, equation 1. Now I'm going to go to the second equation, y2, which means negative x plus 3y equals a negative 5. And this time we're going to solve it for y once again so I can get the slope. So 3y equals negative 5 plus x, which means y is equal to a negative 5 plus 1/3 x. So if you remember what we talked about, if the slopes are different, we're guaranteed that it's going to have one solution. What you have to be prepared for are different variations of this where, and this is a what-if situation, what if this one came back as a negative 3 halves. So just give me the what if it came back a negative 3 halves. Well, if the slopes were the same, but the y-intercepts were different, now they are parallel and never touch, so there would be no solutions. The final scenario would be, what if they ended up coming back, and this is another, the final what if this came back as 2 minus 3 halves x when we simplified it? Well, then we'd end up with an infinite number of solutions. So just trying to cover the bases on all of them because they can tweak that question pretty easily to represent different ideas.